Today I'm going to talk to you about your path to a success vector database. So vector databases are playing an important role for AI, for generative AI and building AI applications yourself. And if your AI is becoming mission critical, vector database is becoming mission critical. So that's why it's really important for you to understand the key properties that matter for your selection of a vector database. First, let's start with what a vector database does actually store. It stores vectors or vector embeddings. And this is just really arrays of numeric data, of floating points. Vector embeddings representing the semantics of some other data, like documents or images in the numeric space. So the most basic thing that the vector database has to support to you is to store these vector data and then allow the application to search for vector data, right? To retrieve vectors that are relevant, that are semantically similar, which means these vectors are numerically close to each other. That's the core function of a vector database, vector search. However, as said, it's mission critical now. So what does it mean? Well, one of the things is performance matters, right? Your performance of this vector search matters. So let's look into more closely what that entails. First of all, it of course means that your search should be fast, right? Because the search does in fact happen in your AI applications in an interactive scenario very often, like a chat application or a co-pilot where a user is basically typing something or he needs to get basically interactively guided to the next step. And he needs to, or he waits for a response if he does a chat message. So the mechanisms that have been established to achieve that are vector indexes. So that's another thing. A vector database needs to support vector indexing. Right? And this vector index is now used in the search situations in order to accelerate these vector searches and make basically this search operation here more time efficient. But there's actually another performance aspect in terms of timing that matters here, because vector indexes need to be built on top of these vector embeddings. So the time it takes to build this vector index is also a critical performance factor to take into account. Another aspect of performance is how accurate does this vector index retrieve these results, because typically the vector indexes that exist, they allow you to do these so-called nearest neighbor searches. They are not an exact retrieval. And depending on your vector index, this can be more or less accurate. So accuracy is another performance aspect to take into account for your vector database and the vector indexes that you employ. Now, beyond performance, what also matters is that these vector embeddings, they are coming from somewhere. They are actually produced and generated based on actual data, like documents and images. If this data is dynamic and constantly changing, these vector embeddings also need to be constantly changed and being updated. So we need to talk about new data that is coming in, and it generates new vector embeddings. And if this is, as I said, dynamic data that is produced in real time, this also needs to be dynamic. So you have a constant real-time flow of new vector embeddings coming in. So we're talking about actually transactions in vector data. So that's an important thing that a vector database needs to support. And this, of course, then has also ripple effects on the other thing. If you have new vector data, then the vector index also needs to be updated. And again, the performance matters now. How fast is that, and so on. Another aspect that is very critical for a vector database selection is what's the scale that you have, that you need, or also that you're expecting. Because you may have started slow today, but if that's a successful application, right, good for you. But then this basically means there's more users and more data coming in here. So scalability of your vector database and your vector workloads, like vector search, more searches, more concurrent searches, and so on. So that's a critical thing that you have to factor in. The next thing is, speaking of mission critical, is security for your data. Right? So this is now data that you're interactively retrieving and feeding into your AI application. You have to be sure that this is not basically leaking any private data or non-compliant data, or just data that you don't want a certain user or a certain application to see. So security is also a feature of this vector database. It has to have access control mechanisms and things like that, maybe even fine granular access control to allow basically the applications to really just get these vectors, which means this data for AI that is applicable in a certain situation or for a certain application. Next, what also matters a lot is how do you make this thing available? Again, mission critical means if that database is down, your AI application is down. So high availability is critical, which means things like, for instance, how to do a backup? Or how do you, when basically the worst has happened, database has been down, the system has been down, how do you restore it? How long does it take, right? Recovery times matter here. Or can you make this highly available by just having standbys? So other high availability mechanisms like standby systems that basically taking over in a failover scenario. So this is critical as well in your consideration. And finally, there's another thing that many people don't have on the radar when they just look at this. Because besides these, I would say, non-functional qualities that the vector database needs to support, vector data scenarios and AI applications are not necessarily working in a vacuum just on the generative AI data. Right? There's other data that you may have already available. You may have data already today in tables. Right? And this information that you may want to use and combine with the vector search. You may not just want to look for the most similar documents, but maybe for the most similar documents that are belonging to a certain user. You may want to filter those. And information what user a document belongs to may just be stored in a table, like in a relational model. So what we're talking about is that these searches here are not always just plain similarity searches. They are often, or that is at least something that provides a lot of additional benefit, hybrid searches, right? Where you want to combine a similarity search with maybe it's just a where clause using some SQL algebra. So you can see that vector databases are not just only about vector search. They have all of those additional properties here that you need to take into account. And this matters when you want to take forward maybe your experimentation of some AI application that you have very quickly pulled together, a generative AI application, when you want to operationalize that. So a successful vector database actually needs to allow you to put AI into operation at scale in an enterprise environment. So the key to remember is that the vector database is also a database. And a database, or databases in general, are mechanisms that are very well established for many years already for operationalization for data-oriented workloads. And the same applies to generative AI now.